Production support for the Friday Zone is provided by
Southern Indiana Pediatrics, with 4 office locations and appointments 365 days a year, is committed to providing quality health care to children and families in Southern Indiana.
the Margaret A. Cargill Foundation, and by WTIU members. Thank you.
Okay, Maddie, if you could travel anywhere, where would you go?
Ooh, I've always dreamed of visiting the pyramids in Egypt.
Okay, close your eyes. All right. Open them.
What? Oh my gosh, that's awesome. How did you do that?
Oh, it's a green screen effect. I'm sorry. I thought I told you.
The week is done and it's time for fun. There's room for everyone in the Friday Zone. So much to see, who will we meet? It all happens magically in the Friday Zone. Friday Zone. Friday. We've been waiting for you. There's so many things we can do. Friday. Gonna learn a thing or two. Play the whole day through. Friday Zone. In your eyes, there's a surprise. You never know what adventure might arise. Friday Zone. Friday Zone. Friday Zone.
Welcome to the show, guys. I'm Maddie.
And I'm Taylor, and today's show is all about exploring far-off places. And to start things off, we've got Dan here to share with us how he goes exploring without even leaving his own backyard. So, Maddie, let's scoot on over. Dan, how's it going? Good to see you again.
Hi.
Nice to see you again.
Good to see you. So you built an observatory in your own backyard.
Yes, I did.
So cool.
Yeah, and what gave you the idea of doing this?
Well, ever since I was young and 8, 9 years old, I got my first telescope, and I always wanted to have one that's easy to use, so I thought the best way to do it is just build one in the backyard.
Cool. And now I know a lot of observatories are named after someone. Did you name yours after somebody?
Yes, mine's named after Richard Feynman.
And who is that?
Richard Feynman was a physicist that was a Nobel Prize winner.
Oh, obviously, and he's a musician.
Yes, he's a musician. And the reason I like him is not just because he was a good physicist, but he was a great educator.
Oh, cool.
And he was able to take complicated issues and make them very simple. So he didn't make people feel as if he knew something that nobody else did. He would find a way to explain it in a very simple term.
Yeah, and he could explain it maybe through a little bongo. So I actually got to come by and see your observatory.
Yes.
And so let's take a look at that right now. Hey Dan, how's it going?
Hey Taylor,
good to see you. So this is it. This is the where's the telescope?
Well, the telescope's inside. We have to crack the roof open first so we can see.
All right, well let's do it. You have a motor that runs this, or are we pushing this with our hands?
No, this one's actually motor driven. Watch your head, you're a little bit tall. But...
Oh yeah. Oh, cool, look at that.
Okay, all we have to do now is put an eyepiece in, and I think we can start observing.
All right, let's do it. I'm gonna lift my sunglasses off so I can look through here. Whoa! Seeing these little flares. What are those? What are those called, Dan?
Well, those are solar prominences, and they're basically magnetic fields that come out of the sun and go back into the sun, and all the hot gas, the plasma, gets stuck and spins around the magnetic field. So like it basically gets stuck
fire
inside.
Loops almost.
Yes.
I mean, it looks like, from here, at small scale, it looks like, like a piece of thread, but it's fire, and it's looping around, and that's the sun. That is so cool.
Yes.
The prominence I'm looking at right now, the kind of the magnetic waves and heat coming off, How big is that in reality? I mean,
The smallest ones that you're seeing in there are larger than the Earth. So the large ones are many times. In fact, if the sun was even more active today, and it varies day by day, some of those will go clear across the sun to the other side.
one prominence.
Yes. So you can see huge ones that will go, so you're talking dozens of times, hundreds of times the size of the Earth.
Dan, this is amazing. This is one hot telescope. Thank you so much for letting us come and check it out.
Well, thank you for visiting, and I hope you enjoyed yourself.
Definitely did.
That was so cool. So Dan, what you guys were looking through in the telescope, you were looking at solar prominences?
Yes, we were looking at solar prominences.
Can you explain a little bit more about what that is?
Sure. The sun has a lot of magnetic fields going across it, and sometimes when the magnetic fields...
Oh, that's what we're looking at right
Yes.
there. That's a
so
solar prominence.
neat.
Yes.
Is that real footage? Or is this just a simulated?
Yes. That's this
What?
here in particular is from a NASA site.
Okay.
But right there around the edge there where you'll see those things that look like loops
Whoa.
and things lifting off of the sun, those
So
are basically
cool.
magnetic fields that collect a lot of gas, hot
Okay.
gas,
Okay.
and every once in a while you'll see them, they're sort of stuck in a loop, and then occasionally the magnetic field will reconfigure, which means it breaks, and then things will shoot off from the surface of the
And
sun.
that's what's happening on the sun right now.
Yes.
Wow.
It's continuously happening.
Well, obviously that's not live footage, but I mean that's what's
Right.
going
It's
on.
happening right now.
Okay, so how big are these prominences? And we're looking at the Earth. How big are they compared to those prominences, the Earth and the prominence?
They can be many times the size of the Earth. As you can see here, the
there.
Earth is really very small,
So
and these
little.
prominences will go halfway across the sun, so they're
Oh my
huge.
gosh.
They're 50, 60, 100 times the size of the Earth sometimes.
Wow.
Wow, look at that. Okay, so
so
now we.
Not an average day, you won't see them that big, but you will
Right.
see, on an
Oh.
average day, you'll see
Wow.
many of them,
So that's a
and they'll be...
great deal larger than the Earth. Just
Yes.
one of those.
Oh,
guys.
yes.
Oh my gosh.
Oh, yes.
Little baby Earth.
Yeah, little baby planet.
Every time you look, you see something different. That's what's interesting about watching the sun.
Yeah.
Because every day, it's something different.
How many Earths across is that? Is about
That's it. You want to count 'em?
30? I think I count 30 Earths. 30 Earths, if that's the correct plural. Cool. Okay, so Dan, what'd you bring with you today?
Well, I brought now the telescope that we went to visit.
Right.
Obviously, is something that you get over many years of building.
Yeah.
But this is similar to a telescope I had when I first started. Relatively inexpensive. It's I don't use this much anymore. But what's nice about it is you can pick it up, take it outside
Portable.
in within just a few minutes. It's like a $200 telescope.
So neat.
The quality is very good. So you can use it to observe pretty much anything in the solar system.
And we were able to look at the sun. Now, I don't recommend anyone just taking a regular old telescope and placing it at the sun and just
Right.
taking a peep. Why could we do that with yours?
Yes, you should never point a telescope at the sun, and if you notice on all telescopes now, they always have a warning, don't
Okay.
point it at the sun. But because if you do, you'll cause yourself to go blind in that eye.
Yeah.
But the telescope that we visited at Feynman Observatory, that had a very specially made filter that was designed for observing
Okay.
the sun.
Okay.
Now, you can also buy similar filters for looking at the white light part of the sun, slightly
And
different.
what's the white light part of the sun?
The white light part of the sun is basically what we see when we look at the sun.
Oh, okay.
It's
Okay.
the photosphere of the
Yeah.
sun, they call it. And
Okay.
what you can buy a simple filter that just basically
Oh, there's it.
makes it not
Oh, that's
quite
so
as
neat.
bright.
Okay.
So you can observe the sunspots. You won't see the prominences and solar flares
Okay,
and such,
okay.
but you'll be able to see the sunspots change every day and go across the sun.
Cool.
But this telescope basically is equivalent to something what somebody would start with. It doesn't take much. You have your telescope, you stick it out. I brought an eyepiece in with me.
Okay.
You would
Neat.
take the cover off here, stick it in,
Right
and
there.
pretty much you're about ready to start observing. There's really not much more you have to do. Setting up the telescope just takes
And
a
how do
minute or two.
you how do you know where to look? What
to
are the
direct
things you
them.
look for? How do you if I wanted to find a certain planet, how do you know where that planet's at?
Well, when I grew up and started using telescopes, you used to have to look, and usually in the newspaper or actually now online in the internet, we'll tell you what planets are where, and you can see.
Okay.
The one thing about observing planets, which is really my specialty,
Right.
it's very easy to find them. You look up in at the night sky, and basically the brighter things that look like stars are really planets. So they're very easy to find. Jupiter is, you could look in the evening sky and find it very easily. Venus, Mercury,
Saturn, Uranus,
Mars,
whatever.
Saturn.
Yeah.
Yes, all of them are very easy to find. So that's what's so nice about it. You don't need tools to find them. You know where it's at, and you could pretty much point your telescope there.
Cool. Well, Dan, thanks again so much for coming in. This was great and sharing with us your little piece of your own backyard that you go exploring with.
So cool.
That's so awesome. And guys, here's a song to explore a little bit more about the solar system on our Friday Zone playlist.
And now another music video from Flocabulary. Hip hop in the classroom at flocabulary.com.
Ladies and gentlemen, transmitting live via UV radio, all the way from the Milky Way galaxy, planet Earth.
Planet Earth. Space is the place, I'm the globe. Bet you didn't know the third rock and roll got soul. In gravitational pull, I orbit around the sun, and every 12 months make a revolution. Or better yet, 365 days as I rotate, change into 9. Why? You should ask Isaac Newton. The law of inertia's governing the movement. Gravity's the force that'll keep us on course. We heading straight toward the sun, but at the same time forward. Flying in space, an elliptical line, it's not straight. The path that I'm destined to have until it breaks. So now you heard of what inertia is. I've been orbiting way more than any person lives. And until another force act on me, run around the sun with the moon on my back. Confessions of a planet. These are confessions of a planet. These are confessions of a planet. Confessions of a planet.
And we ride now to the asteroid belt. Yo, let's go!
With a 25,000 mile circumference of my equator, I'm living long. And as the day gets old, the tilt on my axis controls the seasons, you know. I lean forward and it's warm, or then I lean back and it's chillier than normal. And if my rotation is taking in sunlight, surprise, the heat of the summertime arrives. But on the other side of the equator or my center, people there I enter into winter. Whether you're in the east, by the way that I spin, the sun appears to rise, in the west it descends. Then come follow me to the poles, the bottom and the top of the globe, and it always stays cold. Up to the north and down to the south. Longitude and latitude will keep you on route, but it's all relative in space. There is no direction, there is no escape. Confessions of a planet. These are confessions of a planet. Confessions of a planet. These are confessions of a planet. Even still, man, the sun is 300,000 times more massive, yo. And not to hurt the sun's ego, there's billions of stars, it's just the closest one we know. Regal, at the center of the solar system. The planets are my fam, I can list them. Listen, Mercury, Venus, Earth, Mars, known for being rocky and small, not large. Jupiter, Saturn, Uranus, Neptune are larger and gaseous. Farther and past is Pluto, a dwarf planet made of ice, but even small as what you people call a satellite. Like many planets have it. Mine is the moon, its gravity controls tides too. Move for the asteroid hits. Meteor, comet, but we're a bunch of AUs from it. What? It's 93 million miles to the sun, measured in astronomical units is one.
Yeah, y'all. Hey, yo, quit polluting.
Confessions of a planet.
Let's go.
These are confessions of a planet.
Milky Way. Yeah.
Confessions of a planet.
Blast off.
Hey yo, big shouts to the Milky Way galaxy and Alpha Centauri, you know what I'm saying, the closest star. Hey, yo, this is Earth, I'm out.
Hi, it's me, Bob. Believe it or not, some people think I flew to Earth from a planet called Bub and a tiny space pod.
And now joining us in the zone is Greg, who is a Jet Propulsion Labs NASA ambassador. Now, Greg, what is JPL?
JPL, Jet Propulsion Lab, is located in Pasadena, California.
Okay, that's close to your hometown.
That's right. That's right. It's a beautiful place. It's managed by Caltech.
Okay.
And it's funded by NASA. They're the ones that build all of the planetary rovers and spacecraft.
So they built the Curiosity Rover, which, and actually you brought this with us. Okay, so let's check back on the screen behind us here. We've got this fun app, which I'm sure you all have already played with, where we can take a look at the rover itself. So it's loading up here. Let's take a look. Okay, and let's see, come on. There it is, boom,
Whoa.
Look at that, okay. So this, Greg, this is the rover. This is what it looks like, right?
That's what it looks like.
Okay, let's see what else we got here. We have an arm. Now what's that arm do?
That arm has a variety of instruments and a camera and a laser and
a laser. What's the laser do?
That laser is 10 megawatts. It's powerful enough to be an offensive weapon. But what they do is they shoot rocks with that, vaporize the material in the rocks, and then the camera on that mast will analyze that vapor to see what the materials are made of.
Whoa, cool.
So neat.
Okay, oh, we got some video of that too. No, this is this is what the laser does. So this is what you were just saying. It will shoot a rock.
What it does is that arm is about 7 feet tall. On top of the arm is a camera. There's the tools right there, the various drills that they use to take sample materials from the Martian surface. You can see it as it moves down to take a sample right now.
Oh, cool. And what are they looking for in these samples?
They're looking for signs of past life. That's what they're looking for.
Oh, okay.
That's the mission of the Curiosity Rover is to, there's 4 major goals that need to be accomplished here. Number 1, determine if life has ever arose on Mars.
Okay.
Number 2, to characterize the climate of Mars.
Okay.
Number 3, characterize the geology of Mars.
Okay.
And number 4, and probably most interesting, is to prepare Mars for human exploration.
So we can eventually go there.
So we can go.
How the heck did we get this thing on Mars?
What a feat. This was the largest rover that has ever been launched into space. It's about the size of a Mini Cooper car.
Oh, wow.
About 2,000 pounds. And it launched.
Oh, there it is.
Here we go.
Whoa.
It launched November the 26th of last year, 2011.
Okay.
That's in Earth orbit on its booster. That top part that just detached is called the cruise stage.
Okay.
About 8.5 months later, almost 200 million miles.
Wow.
It's going to approach Mars. There's its, some of its solar panels.
Okay.
It's called the cruise stage. 8.5 months later, it's approaching Mars. This is a direct approach.
Okay.
It's going to land in a landing zone about 12 miles in diameter. There, the cruise stage just ejected. It has a 14-foot diameter heat shield, largest heat shield ever flown in space.
Wow.
It's entering the atmosphere about 13,000 miles an hour.
Oh my gosh, that's fast.
Those little jets you see in the back are able to guide it as it enters Mars' atmosphere. It's going to slow down considerably to about 1,000 miles an hour. This all happens in about 7 minutes. Everything we're watching. It's going to eject that heat shield, and a parachute comes out at about 1,000 miles an hour. It's called a hypersonic parachute.
Oh my gosh.
The heat shield drops away.
Okay.
And now, watch this. The descent stage will eject from the spacecraft.
Oh my gosh!
The rockets fire up. Now, it can't get too close to the surface because those jets will kick up too much dust, which will coat the Mars Curiosity Rover. So it's going to lower that rover on cables. They're nylon cables, about 20 feet long. You'll see this happen.
Okay.
First time this has ever been attempted. This was called the 7 minutes of terror.
I'm sure.
JPL.
No, I remember watching the night that it was landing. I remember watching the whole control room.
That's right.
And they were on pins and needles.
This is about a 14-minute delay between Mars and Earth. They didn't know. This is all automatic. Once it touches down, it severs the cables. The descent stage vectors off and crashes onto the surface. Now Mars sends, the Curiosity Rover sends back a signal that it's down safely, the wheels are on the ground, and the mission control people at JPL then send the signals up to fire up all the systems and start to test it.
Well, you know, you tell somebody what your plan is to get this rover on there, and it sounds ridiculous. You know? But that's one of the most amazing things
it is
I've ever seen.
As a matter of fact, it was all done by computer control because it was all hands off by the mission control people at NASA. And the computer program for landing the rover was so big that when after the lander landed, It dumped that program out, and then they reprogrammed it from Earth for all the operational software.
So, and there's an actual picture from Mars. That's beautiful. That is so. I mean, it looks like you're looking at one of our deserts. You know,
looks like Arizona.
So what is Curiosity doing now?
Well, they spent several days testing all of the systems.
So it took a while. It wasn't moving right away.
It took almost 4 or 5 days just to get the new software loaded in, because they have to do it a little packets at a time. And it's going to test the wheels. It's going to move a little bit, and they're going to camera.
There are the wheels.
Yeah, this was taken actually in the clean room at Jet Propulsion Lab in Pasadena.
What's the clean room?
Everybody wears smocks in that clean room. That's where they assemble the spacecraft and get it ready. These are still images taken. That camera can actually look at itself. And so it can check itself out to make sure everything's okay.
Yeah.
And there's some of the tracks it left in Gale Crater where it landed.
Yeah.
It was actually, the landing zone was called the Bradbury Landing, named after Ray Bradbury, the science fiction writer.
Wow, and it's doing all of this right now. This is so amazing. What are future goals or plans with Curiosity?
Well, it's a 2-year mission. Powers everything, as you know, and the power supply is a nuclear power supply. It uses natural decay of plutonium-238 and thermocouples to change that to electricity. That power supply is good for about 20 years.
Wow.
Even though this is a 2-year mission, hopefully by the end of those 2 years, if NASA funding continues, they can remission the Curiosity rover and have it perform other tasks for several years in the future.
Cool. So that's where it's headed.
It's called Glen Elg. That's about 400 yards east of the landing zone. It'll take 2 months to get there.
Wow.
2 months.
And why is it going there specifically? What are they looking for there?
Well, they're stratified layers of geology there. They feel as though Gale Crater is rich in clay. And they're looking for signs of past life on Mars and hydration, water, etc. And they saw stratified layers there on the side of that mountain, and they're going to go look and shoot some of that with a laser and drill some and sample the materials, etc. inside of its chemical analyzer.
Oh, and what is this? Is this back in the clean room?
This is back in the clean room at JPL when they were testing the systems prior to putting up on top of the rocket and launching it to Mars. You see everybody's wearing clean room suits. We don't want to take any germs up there with us.
No.
We might be able to find microorganisms that actually came from here. So
look at that, Mars.
Looks like Arizona, doesn't it?
Oh yeah.
It really does.
If we want to learn more about Curiosity or Mars or anything in general, is there a website we can go to?
Yes, you can go to, NASA has several websites actually. JPL has their own websites. The best way to find those several involved. Go to Google and just Google Mars Curiosity, and there's a there's the address right there for for NASA's website. It's great information.
And let's say kids want to go and observe space on their own. Where can they go to look up at the stars or look up at Mars or whatever?
Well, just south of Indianapolis, just south of Mooresville actually, is the Link Observatory and Space Science Center. And the observatory is
that's where we met originally.
That's where we met. We have a giant 36-inch telescope there, and we put on regular programs for the general public as general interest programs about Mars, about planetary exploration, about
that's great.
Things like that.
And they can find information on when that's going on the website?
On the website, linkobservatory.org.
Cool, Greg, thank you so much. Always a pleasure seeing you.
So neat.
Nice to meet
and
you.
Maddie, let's check out some more stuff on the app. What do you want to look at? Let's see.
You can move it, right?
Yeah. Well, we can look at other things too.
What's Juno?
Juno. What's Juno?
Juno goes to Jupiter. It was launched about a year ago.
Hello, welcome to the Earthy's Test Kitchen. My name is Heather, and today we're going to make banana berry smoothies.
Banana berry smoothies?
They're my favorite.
Yeah,
I love smoothies.
Felix has never had one before. What is
Really?
in a banana berry smoothie?
Well, today when we make it, we're going to use frozen yogurt. It's a good low-calorie way to make your smoothie thick, kind of like a shake, but a healthier version. It's really good.
Healthy, yeah. Felix loves healthy snacks. Yeah.
Well, that's good. Do you like strawberries? And if you like bananas, then you're in for a treat. You're gonna
Felix
really
loves
like it.
strawberries and bananas.
Well, good. Well, let's get started.
Okay. What do we put in first?
Well, first, I'm just going to put in a cup, one cup.
Okay.
A big scoop.
Okay. Big scoop.
of vanilla frozen yogurt.
Yeah. And you're putting that in the blender.
I'm putting it in a blender.
Okay.
It's a safe kitchen appliance. You'll be
Okay.
okay.
So-
as
so-
long as you put the lid on before you use it.
Yeah, because if you don't, Felix learned you make a big mess.
Yes.
Yeah. We don't want the yogurt to get everywhere.
No, and it will.
Yeah. And I don't want you to get the yogurt in your hair, Heather.
I don't either. That would be a sticky mess.
Yeah.
So you put a cup in there of frozen yogurt. And now I'm going to put in some strawberries. Just a few.
My favorite.
And you use more if you like them.
Okay.
Less if you don't.
Felix might use more. Yeah.
So would I.
Yeah.
And they're really good for you, and they're in season right now. And I'm going to use a banana. Do you like bananas?
Yeah. Felix loves bananas. Heather, remember I told you monkeys eat bananas.
Right.
Yeah.
And do you like monkeys?
Yeah. Felix loves monkeys. They are Felix's favorite animal.
They're my favorite thing to see at the zoo.
Yeah.
So I'm going to put this banana in there, and it's really easy to peel. Anyone could do it.
Yeah. Oh, that looks good. Felix can use a blender. I've used a blender before. Yeah.
Yeah, it's easy. You can do it.
Okay.
And then all I'm going to add is some cranberry juice.
Oh, okay.
It's good for you.
Yeah.
It gives it some pretty color.
Do you make that from cranberries?
You do.
Oh, okay.
Okay, I'm going to put the lid on.
Oh, yeah.
And it's a little loud.
Right. So I'm going to cover my ear. Okay.
Yes, cover your ear.
Yeah. Okay.
Okay, here I go.
Okay. It's not so loud. It's not so loud anymore.
Okay.
Yeah.
And that's it.
That's it?
It's really easy.
Can we try it
Yes.
now?
And I'm going to pour it in a glass.
Oh, okay.
Use any glass you want.
Okay. Ooh, that's a fancy glass head.
Yeah.
Look at that.
And it's pretty. It's good for you. It gives you some good energy.
Okay.
It's a great after-school snack.
Yeah.
Here you go. And look.
Okay. Yeah.
I even have a pink umbrella.
Oh, Heather is so nice to Felix. She puts an umbrella in my drink. Okay, can I try some?
Yeah, try some. What do you think?
Heather, that is the best!
Thank you. And it was really easy too, wasn't it?
Yeah. You just put it in the blender and you mix it and you push the button and now Felix has a good, healthy drink.
Hey everyone, here's that recipe again. You can write it down or go to our website and watch Earth Eats right on your computer. Yeah, eating smart is more than easy. It's super simple.
In the Friday Zone.
Well, guys, that's all the time we have for today. I want to thank Greg and Dan for both coming in and teaching us a little bit about outer space. Thanks for having us.
So remember to live, learn, and play the Friday Zone way. We'll see you here next week.
All right, Greg, favorite planet?
Yes.
Saturn. Saturn, why Saturn?
Production support for the Friday Zone is provided by
Southern Indiana Pediatrics, with 4 office locations and appointments 365 days a year, is committed to providing quality health care to children and families in Southern Indiana.
the Margaret A. Cargill Foundation, and by WTIU members. Thank you.